Good morning, good afternoon, good evening. This is Mr. Payne bringing you one of the last videos of the year, sequencing review. So the first type of sequencing that we're going to review and talk about today is arithmetic. Your arithmetic pattern, which is a plus or a minus pattern, which is your D. Your D stands for your common difference. So how do I remember that and keep it situated and separated? I always think of the letter A. In arithmetic goes along with adding. So if my pattern, like in this case, in the example, my pattern here is plus 2, that's how I know it's going to be arithmetic. One other connection I would like you to make before we talk about the rest of these formulas is that the arithmetic sequencing goes directly in hand with linear functions. At first, this topic was very difficult for me to even comprehend and really wrap my head around until I figured out that it is just a function of a linear, and I could set it up as a table to sort everything out and organize everything. So the formula, we spent some time with the formula this year, but we focused more on the table and understanding what was happening with the table to link it with the linear functions and sequencing and arithmetic altogether. But if you want to use the formula right here is a sub n equals a sub 1 plus n minus 1 times d. And once we go into this vocabulary a little bit more, a sub n is the nth term, the term that you are looking for. A sub 1 is my first term. So when I go over here to the example, find the 10th term of the sequence, one way to organize this is by setting up a table, x and y. And your x is your term, and that's your n. It can be used interchangeably, so that's your term, a sub n. So my first term, my second term, my third term, my fourth term, my fifth term. And right here it's given to you. My first term would be 3. That would be a sub 1. A sub 2 would be 5. A sub 3 would be 7. A sub 4 would be 9. And because it's a plus 2 pattern, I can go ahead and continue. Now to find the answer, the 10th term, you can continue your table. And on an exam, pardon me, if you're on your exam and you have 3 hours and you really can't remember what to do, what's the harm in writing it out? The only harm that you have is exactly what I did there. I made a mistake and I only added 1 instead of adding 2. So that should be a 3. That would be 15. That would be 17, 19, and 21. So a sub 10, my 10th term, would be 21. Now as you look over here to the right, here's how you would solve that same type of problem. A sub 1 equals 3, D equals 2, and I would plug it into my formula. My a sub 1 is 3. Plus my n, what I'm looking for is 10, minus 1 is part of my formula, times 2. And when you type this all into your calculator, you get 21. We're going to shift gears now and talk about geometric sequences. A geometric sequence, pardon me again, is a pattern with multiplication or division. We don't always say division anymore. Remember that division is really multiplying by a fraction. Just write that note down. Multiplying by a fraction. Your formula, a sub n equals a sub 1 times r raised to the n minus 1 power. Don't forget that a sub n is still your nth term. A sub 1 is your first term. And the new thing here is r. R is your ratio that is multiplied. So your r is your ratio that is multiplied. R stands for ratio. So if we're looking for the 7th term of the sequence again, and you want to still having a hard time comprehending this, you can set up your x and your y, your table, and you have your your first term would be 2. Your second term would be 6. Your third term would be 18. Your fourth term would be 54. And I want to go up to 7, so I'm going to continue it on to 5, 6, and 7. And what am I doing here? It looks like I'm multiplying by 3 each time. Multiplying by 3 each time. So 54 times 3, I'm just pulling out a calculator to continue my math, would be 162. Times 3 would be 486. Times 3 would be 1,458. That would be my 7th term. Now, if you don't want to carry that out, you can look right over here. You type in your formula, a sub 1 times r raised to the n minus 1 power, 2, which is my a sub 1, times 3 raised to the 7 minus 1. 7 minus 1 would be 6. Tie you into the next slide. Don't forget what that n minus 1 stands for. That n minus 1 stands for my recursive, or the term before it. So as you're thinking about stuff and you don't want to plug things into your formula, the n minus 1 notation stands for the term before it. Term before it. The previous term. I just mentioned it and I talked about it. The recursive formula. Recursive, a way of writing the pattern by reference to the previous term. There is that word previous, or term before it, previous term. In this case, they told you that it's a sub n plus 1 equals a sub n, which is the case, but you're going to see it all types of ways. The key is that they have to tell you, if they're going to use the recursive formula, they have to tell you a sub 1. So this is a great example for you to highlight right here if talking about recursive. And I'll walk you through it real quick. What is it talking about? This formula is saying that my first term is negative 4, and I'm going to take the previous term before it, and I'm going to add 5. That's my pattern change. And because there's no multiplication here, I know that this is a arithmetic sequence because I'm adding 5. So the first thing I do is I go ahead through and I set up my table. And I say my first term is negative 4. My second term is provided 2. I have to add 5 to that. This is going to give me 1. My third term, if I add 5 more, will give me 6. My fourth term will give me 11. And so forth. And I keep going right down. Now, this here to me, that's confusing looking at all of that. I make more sense by using a table and setting it up. And I want you to think about that and remember that. When you turn this piece of paper over, you're going to have questions that are tricky. A lot of reading or pictures. I want you to remember to continue to set up your table. Whether it's the first picture, the second picture, or the third picture that you're comparing, you still set up. That's my first term, my second term, my third term. And it'll be able to help you set it up. Now, one thing that I forgot to mention on slide 1. If you're dealing with linear functions and you have a table, let's remember that you can use your calculator as a tool. You can always, once you have your table, can't you hit stat edit? Then you can hit stat calc 4 for a linear function. And didn't I tell you that linear ties directly in with arithmetic? What you always can do is then go to y equals, type in the equation that they gave you, and go to your table. To find your end. I hope that makes sense. We're going to go through that a little bit more depth with the questions on the back. We're going to take our time and go through each question on Tuesday. Have a great long weekend. Come back rejuvenated and refreshed.